4.3 is continuing our conversation of proving triangles are congruent. So in section 4.2, we learned about side, 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 and side, angle, side. So there are two other shortcuts in this section, angle, side, angle, and angle, angle, side, that can also be used to prove that triangles are congruent. So the order that we say these words, angle, side, angle, is important because angle, angle, side, and angle, side, angle. Notice they both have two angles, but the order that we put them in is important. So the first one is angle, side, angle. It says if two angles in the included side, so if you have two angles and the side that's between them, okay, and so if we had the same two angles and that same side between them being congruent, then we can say those two triangles have to be exactly the same size. They have to be congruent triangles. And then the same thing for angle, angle, side. So it doesn't matter which order you go in, but the side is not going to be, it's not going to be between. Otherwise, that would be the angle, side, angle. So if we start rotating around the circle or around the triangle this way, we would have an angle, then the next angle that's next to it, and then the side on the other side. So here we'd have angle, we'd have an angle. Oops, I did it the wrong way. So angle, angle, and then the side. So as we go around that triangle, that's how they're equal to each other. So it's a little tricky, but let's try some examples. So it says, is it possible to prove the triangles are congruent? If so, state the postulate or theorem that you use. So in this case, we have two angles marked. So we have an angle here, congruent to the angle in the other triangle, and then an angle here, congruent to the angle in the other triangle. And then we have the side in between them, okay? So as we go around the triangle, we're going to have the angle, then the side, then the angle as we go around. Okay, so this is going to be by angle, side, angle. Okay, so when we write the congruent statement, so if I ask you to do this on the test, you should know what it says, what it means. This would be like angle OP, or not angle, triangle OPM is congruent to, so if I went 2 markings to no markings to 1 marking, I want to go 2 markings to no markings for the angle to 1 marking. So I'm going to say triangle ONM. Okay. So on the next one, we again have a shared side. So we have that shared side on the last one. And as we go around, we have an angle, and then we have a side. Okay, so this is angle, angle, side. Now some people say SAA, but really know your 4 that we know so far. So far we have side, 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 angle, side, angle, side, angle, and angle, angle, side. So I would write it the correct way. Okay, and these are going to be congruent by triangle ZW or ZVY is congruent to W. So I went to 1 mark, 2 marks, and then the side mark. So I'm going to do 1 mark, 2 marks. So WVY. All right, so the next one, it has some markings that you should know what they are. So every time you see these little triangles here, these little arrows, that means that we have parallel lines. So one thing that helped me when I was in geometry is I always extended those lines and then looked for a transversal. Okay, so in this case, this would be a transversal. And because of that, this angle right here and this angle right here are congruent to each other. Okay, and that's by corresponding angles, right? So let's write a little note to ourselves. So corresponding angles. And they're congruent to each other. So then with that, we have angle, side, angle. So the angle, the side, that's marked congruent, and then the angle. And that's for both those triangles. So these are congruent by angle, side, angle, and we're going to say triangle AEB is congruent to triangle BDC. So same idea on the next one. Again, we have these parallel lines. So if you extend them and then look for a transversal, it looks like we have a good transversal here. I always look for the Z shape, and inside the Z we have alternate interior angles. So let me mark with 2 marks since we already have 1 mark there. So these 2 are called alternate interior angles. Okay, so looking at our other marks though, if you notice that in our original, we didn't have any sides, right? So we don't have any sides marked in, but we do have a shared side. So we had these 2 angles are the same, and we have this shared side here. Okay, so really if we only had angles and we didn't have sides, we couldn't say that they're congruent, because think about equilateral triangles even. If I have 2 equilateral triangles and I have even all these angles are congruent to all these angles. They're all 60, right? These two triangles are not congruent to each other because they're not the same size. So we do have that shared side though. So as we go around, we have the angle, and then the side. Okay, so this is angle, angle, side. And we would say that triangle FGJ is congruent to triangle HJG. All right. So number 2, so it says fill in the statements and reasons proof. So this one doesn't have anything given to us. So, I mean, it doesn't have anything in under the statements or under the reasons. So we got to do the whole thing. But we were given that AB is parallel to DC. And we were also given that AB is congruent to CD. So let's draw in some markings. So we know that AB is parallel to DC. We draw the little triangles in. And then we know that AB and CD are also congruent. So now we do the little tick marks as well. Okay, so we have those markings. So remember I said whenever you see parallel lines, extend them and then think about a transversal. So let's use this transversal. It actually doesn't matter which one we use. Okay, so what angles could we say are congruent? Well, we could say that this angle is congruent to this angle, right? By alternate interior angles. So let's write it. So let's say that angle B is congruent to angle D. And our reason was by alternate interior angles. And you can write alternate interior angles theorem if you want. So number 3. So let's see what else we can get. Well, we know we have this side. So we have these sides are congruent. And we know we have an angle. So if we got angle, side, angle, or if we got angle, angle, side, we'd be good to go. Or if we had side, angle, side, I guess. But it doesn't look like we can do any other sides, right? So what can we do? So look at the picture really carefully. How about these angles right here? So we're going to say that angle AEB is congruent to angle CED. And that's by vertical angles. So that means that we have enough to prove that our triangle ABE is congruent to triangle CDE, because as we go around, we have a side, we have an angle, and an angle. So let's say it in the correct order. So let's say angle, angle, side. So you could write out angle, angle, side, congruence postulate. But if you just write angle, angle, side, I'm cool with that. Okay, I'm not going to be the super picky geometry teacher. All right, so that's our first proof of this. All right, so the next one is paragraph proof. So these can be a little bit harder. And you can write a statements and reasons if you want to. Or we're trying to prove these two triangles are congruent. So luckily we have some things that are given to us. So we know that angle R is congruent to angle T. And we know that angle TQS is congruent to angle, what do we have? TQS. So let's do RSQ, right? So we know this because these are given to us. All right, so we at least have angle, angle. And we can't do the one that's angle, angle, angle. That doesn't work. That's because the equilateral triangle thing we talked about. So looking here, sometimes it helps to separate our triangles. Whoops, that was a crazy line. So we have this red triangle, and we have this blue triangle. So let me draw them separately. And we'll see what we have. So we have RQS, and then we have the red one, which is TSQ. So this is always a great method to try if you're not sure what's congruent to what. So we had those two angles were the same. And then in the blue triangle, we had that this angle, angle S, so RSQ, was the same as the red triangle, TQS. Okay. So we're nearly there. So we need some kind of side to be the same. And if we got these ones were the same, we could say angle, side, angle. But looking at our picture, it doesn't look that we can get this one to be the same as this one, right? Oh, sorry, not that one. I marked it in the wrong spot there. So it doesn't look like we can get this one to be congruent to this one in our picture, okay? We don't know how to do that. But if you look for something else, so if we think, okay, angle, side, angle didn't work, but what about angle, angle, side? That would be here and here. And how can I say that QS is congruent? So, well, QS, right? So we're going to say QS is congruent to Q and then S. We'll say S and then Q. And you can say by the symmetric property, or you can say same segment. I'm fine with that as well. All right, and then we have it. So we can say triangle TQS is congruent to triangle RSQ by angle, angle, side. We're done, okay? All right, so the question is, why does SSA not work? So I kind of mentioned this in class yesterday. So SSA, I know that it's the bad word spelled backwards, right? ASS. But that's not the only reason it doesn't work. So I get that we don't want to write that in capital letters throughout a geometry book, but it also just doesn't work, okay? And we can play around with this, and I'll probably have you guys do this on Friday. But let's say I had 30 degrees, and I had 30 degrees here. And then I have a side length of 15, and then maybe a side length that's slightly shorter, so maybe a side length of like 14. Okay, this 14 can swing around. You could have an isosceles triangle here where these two sides are the same, okay? So that 14 could actually be in two different locations. It could be here, or you could pretend it's on a hinge and you could move it over to here. So when you do that, you have two triangles that have the same three measurements. They have an angle that's the same, right? So these angles are the same. They have a side that's the same. And then they have a third side, or a second side that's the same. Okay, so angle, side, side. So we write it as SSA. And that won't work because these aren't congruent triangles. I can't take this triangle I'm shading in blue and put it on top of the triangle in red and say that those are the same triangle. They don't match up. Okay, so side-side angle is actually the bad one. It doesn't work. The other one that doesn't work, like I talked about, is angle, angle, angle. Also doesn't work. But any other combination works, okay? So the ones that are on our list, so what works? So right now we have four. We have angle, angle, side, angle, side, angle. We learned those today. We have side, 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 and we have side, angle, side. The only other one that we're going to talk about is what we call hypotenuse leg, okay? And that will be tomorrow. We'll talk about that. That is a form of SSA that actually works. So that's only when you have a right triangle. And we'll talk about why that would be true, why that would work. It's basically because the Pythagorean theorem tells us that there's only one other measurement that we could have. So HL is the only other one that will work. Okay, so it says decide if the following triangles are congruent. If so, list the congruence postulate used. Okay, so the first one. So we have a side, and then we have an angle, and then a side. And over here we have the same order, side, and then angle, and then side. So because of that, we can say that these triangles are congruent by side, angle, side. So the next one looks like it would be angle, 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 but remember that's one that does not work. Okay, so angle, angle, angle doesn't work, so this is, they are not congruent. So if you think about a triangle that maybe has like 30, we'll do 30, 60, and 90. I could have another triangle that has the same measurements, right? 30, 60, and 90. It's just bigger, okay? So those aren't congruent triangles. Those are what we call similar triangles. They're similar in shape, but they aren't the same size. All right, so the next one. This is a tricky one. This is actually the HL because we have the hypotenuse and we have a leg congruent. So let's kind of think about why this would be true, and we'll talk about it in another section as well. So what if I had numbers on here? So what if I knew that this one was 3 and this one was 4? And I knew that this one was 3 and this one was 4. Since we have a right angle for both of these, that determines what that other, whoops, I did 4 up there, but that's fine. That determines what this other side ends up being. Okay, so we could do Pythagorean theorem. We could say 3 squared plus x squared equals 4 squared. And we could find that x value. It ends up being the same for both of them. So really, it ends up being side, side, side in the end. But this is by HL. So that's a tricky one. I don't know why I put that so early. All right, so the next one, go around in order. We have an angle, and then we have a side. Okay, so we're going to say angle, angle, side. The next one is side, 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 clearly. And this last one is side, angle, side. So the only one that didn't work was this one right here. All right, let me stop that.